Hello, we are AccuRobotics and our project is the robot-based load measurement system version 0.1. For our project, we calibrated a sensor that can be used to measure the dynamic loads that a robot base experiences during robot operation. To start, we built a base that could be used to measure the loads in the sensors. Our initial concept consisted of two springs that would pull on some eye bolts that would create a load in our original sensor design, two aluminum bolts with strain gauges mounted inside. We needed to find the spring constant for the springs that we were using in our setup to figure out what force we were applying to our sensors. So we built a frame and used a force gauge to measure the forces on the springs and used a caliper to measure the lengths of the springs. We then used least squares regression for a linear fit to find the spring constant for the springs that we were using. On the computer and electrical side of things, our system was run using an Arduino Mega. We had two strain gauges connected to two Wheatstone bridges that then ran through two different amplifiers back to the Arduino. This was to measure the change in voltage across the strain gauges as force was applied. We glued our strain gauges to the inside of the bolts that we would use as our sensors. We then tested our setup to see if we can get loads measured through the bolts. However, we ran into an issue where we couldn't measure any loads. We started to do some debugging of our circuit program and system to see what the issue was. We ran the code with a potentiometer and we figured out that the circuit was fine and the program was fine. We discovered that the issue was the bolts were required 25,000 pounds of force to get a readable measure. We switched to plan B, which was to use a load cell with a 20-pound maximum to see if we could calibrate it and get an axial load. This worked great, and we decided to run our calibration using this load cell. We then ran a linear fit on the measurements we got to figure out what different voltages we could read for each force applied to the load cell. Our next steps are to apply dynamic loads to the load cell using a stepper motor, and then try using greater forces to get measurements on the bolts.